Hello friends, welcome to the channel. Today we will be discussing about what Chandrayaan II has given us. The detailed information will be helpful to all of us. Although the soft landing on the moon failed, the orbiter has been doing its job. 2 years on, ISRO has released the information gathered, from confirmation of the presence of the water molecule to data about solar flares. The failure of Chandrayaan II, India's second mission to the moon, to make a soft landing on the lunar surface had led to much disappointment. The lander and rover malfunctioned in the final moments and crash landed, getting destroyed in the process. But that did not mean the entire mission has been wasted. The orbiter part of the mission has been functioning normally, and in the 2 years since the setback, the various instruments on board have gathered a wealth of new information that has added to our knowledge about the moon and its environment. ISRO has released the information gathered by the scientific payloads, some of which were still to be analyzed and assessed. What is the information gathered from Chandrayaan 2? The orbiter is carrying 8 instruments. Through different methods, these instruments are meant to carry out a few broad tasks. Study in more detail the elemental composition of the lunar surface and environment. Assess the presence of different minerals and do a more detailed mapping of the lunar terrain. ISRO has said each of these instruments has produced handsome amount of data that sheds new light on the moon and offers insights that could be used in further exploration. Some of the most significant results so far are water molecule. The presence of water on the moon had already been confirmed by Chandrayaan 1, India's first mission to the moon that flew in 2008. Before that, NASA missions Clementine and Lunar Prospector 2 had picked up signals of water presence. But the instrument used on Chandrayaan 1 was not sensitive enough to detect whether the signals came from the hydroxyl radical or the water molecule. Using far more sensitive instruments, the imagining infrared spectrometer on board Chandrayaan 2 has been able to distinguish between hydroxyl and water molecules and found unique signatures of both. This is the most precise information about the presence of water molecules on the moon till date. Previously, water was known to be present mainly in the polar regions of the moon. Chandrayaan 2 has now found signatures of water at all latitudes, although its abundance varies from place to place. The imagining infrared spectrometer characterized hydration features in the North Polar region on the far side of the moon and also quantified the hydration within a crater. Besides, the dual frequency synthetic aperture radar, a microwave imaging instrument, has reported detection of potential water ice at the poles, as it has been able to distinguish properties of surface roughness from that of water ice, which is a first. Through Chandrayaan 2, we got to know about minor elements as well. The large area soft-ray spectrometer measures the moon's X-ray spectrum to examine the presence of major elements such as magnesium, aluminium, silicon, calcium, titanium, iron. This instrument has detected the minor elements chromium and manganese for the first time through remote sensing. Thanks to a better detector, the finding can lay the path for understanding magmatic evolution on the moon and deeper insights into the nebular conditions as well as planetary differentiation. Sodium, also a minor element on the moon's surface, was detected without any ambiguity for the first time. Scientists at ISRO believe that based on the class findings with respect to sodium, a direct link of exospheric sodium to the surface can be established, a correlation that remains elusive till date. The finding also opens up the avenue to explore processes causing the sodium to be present on the surface as well as the exosphere. Chandrayaan 2 gave a detailed study on the Sun, one of the payloads called Solar X-ray Monitor. Besides studying the Moon through the radiation coming in from the Sun, has collected information about solar flares. XASM has observed a large number of microflares outside the active region for the first time, and according to the ISRO, this has great implications on the understanding of the mechanism behind heating of the solar corona, which has been an open problem for many decades. While the orbiter payloads build upon existing knowledge of the Moon in terms of its surface, subsurface, and exosphere, it also paves the path for future Moon missions. Four aspects: mineralogical and volatile mapping of the lunar surface, surface and subsurface properties, and process involved quantifying water in its various forms across the Moon's surface, and maps of elements present on the Moon will be the key for future scope of work. A key outcome for Chandrayaan II has been the exploration of the permanently shadowed regions as well as craters and boulders underneath the regolith. The loose deposit comprising the top surface extending up to 3 to 4 meters in depth. This is expected to help scientists to zero in on future landing and drilling sites, including for human missions. What we missed because of the crash landing? The most obvious miss has been the opportunity to demonstrate the technology to make a soft landing in outer space. ISRO scientists maintain that the accident was caused by a relatively small error that has been identified and corrected. But to demonstrate this technology all over again, ISRO would have to send a fresh mission, Chandrayaan III, planned for next year. It is expected to have only a lander and rover and no orbiter. The lander Vikram and rover Pragyan were carrying instruments to carry out observations on the surface. These were supposed to pick up additional information about the terrain and composition and mineralogy, while the instruments on board the orbiter are making global observation. Those on the lander and rover would have provided much more local information. Those two diverse sets of data could have helped prepare a more composite picture of the Moon. Though Chandrayaan II was a failure, it was not a total heartbreak for the Indian scientists. We want more moon missions to come up for the benefit of the world. Thank you. Keep watching our video.